Okay, welcome back. This is section 4.2. We're going to talk about function composition as well as inverse functions and relations. So in this video, we are going to learn how to write a function that combines other functions. We're going to talk about how to find the inverse of a function. We are going to talk about how to use composition of functions to determine if two functions are actually inverses of each other. We're also going to talk about how to use a graph or a table of a function to determine the value of that function's inverse, and how to restrict the domain of a function whose inverse might not be a function so that we can go ahead and make sure that that inverse is actually a function. Okay, so first thing we need to remember is how to add and subtract functions. This may look a little different, but it's basically what we did with evaluating polynomials. So for example, in example 1, if we're adding f of x, we take whatever f of x is, so 3x minus 2, and we're going to go ahead and add g of x. So add g of x, which is x squared, plus 5x minus 2. And now we have like terms to combine. So when we combine those, we have x squared. And then 3x plus 5x is 8x. And negative 2 minus 2 is negative 4. And so f of x plus g of x equals x squared plus 8x minus 4. We can do the same thing with subtraction. So here we're going to take g of x, so g of x first, so x squared plus 5x minus 2, and then we're going to subtract f of x. Now since we're subtracting the entire quantity of f of x, we're going to put that in parentheses because we need to subtract each term separately. So when we rewrite this, we have x squared plus 5x minus 2, now minus 3x, so minus 3x, and minus a negative 2 is plus 2. So now we can combine like terms. So we have x squared plus 5x minus 3x is plus 2x, and plus 2, or minus 2 plus 2 is 0. So g of x minus f of x is x squared plus 2x. In the next example, we're going to do 2 times f of x. So that means we're going to multiply f of x by 2 first, and then we're going to go ahead and subtract g of x. So we're going to do 2 times f of x, and remember f of x is 3x minus 2, and then we're going to subtract g of x, which is x squared plus 5x minus 2. So we need to distribute the 2 and multiply 3x minus 2 by 2, so we end up with 6x minus 4. And then over here, remember we're subtracting each of these terms separately, so minus x squared minus 5x plus 2. And when we combine like terms, we have negative x squared. 6x minus 5x is plus x. And negative 4 plus 2 is minus 2. Okay, we can continue with function operations with multiplication and division. Same thing, we're going to go ahead and substitute in each of the expressions we're given for each of the different functions. So in the first case here, we have f of x divided by g of x. So f of x divided by g of x. So f of x is x squared minus 9 over g of x, which is x plus 3. Now we can do synthetic division or long division, or we can recognize that x squared minus 9 is a difference of squares. So we can rewrite that as x plus 3 times x minus 3. And of course that's all over x plus 3. And now x plus 3 divided by x plus 3 is just 1. So our answer is x plus 3. For g of x times f of x, so we're going to do g of x, which is x plus 3, times f of x, and f of x again is x squared minus 9. Now we can use the distributive property, so x times x squared is x to the third. X times 9 is minus 9x. 3 times x squared is plus 3x squared. And 3 times negative 9 is negative 27. We are not required, unless it says write it in standard form, we are not required to put it in standard form, but I'm going to go ahead and put it in standard form, so that way we can check our answer quickly. And I forgot about domain and range. Okay, so the domain of this function here, right, x plus 3, we would think would be all real numbers, except for the fact that if I put a negative 3 in the denominator here, that would make this function not work, right? So if I put negative 3 in and found f of negative 3 divided by g of negative 3, g of negative 3 would be 0, and you can't divide by 0. So the domain here, we would first think that it would be all real numbers, but actually it's going to be everything except, so all real numbers where x is not equal to negative 3. Okay, so all real numbers but not negative 3, because negative 3 would make g of x 0, and then that wouldn't work. This function here, so if this is our answer, our final domain we look up here, there's no reason why we can't put any value in for x. So x is all real numbers. So we can use interval notation and write it as negative infinity to infinity. So the domain for this function would be negative infinity to infinity. Okay, for this example, so we're going to do 2 times g of x, negative 2 times g of x, times f of x, times f of x. And so negative 2 times g of x, which is x plus 3, times f of x, which is x squared minus 9. Now, since this is all multiplication, and I've already done g of x times f of x, I know that this is negative 2 times the quantity x cubed plus 3x squared minus 9x minus 27. And so now all I need to do is distribute in the negative 2. So negative 2x cubed minus 6x squared plus 18x plus 54. Okay, and of course the domain here, this is a polynomial, so we can put any number in that we want for x, because there's no reason x can't be anything between negative infinity to infinity. Okay, go ahead and take a moment. I want you to try these. I will go ahead and pause the video, and when you come back, we'll do one at a time and see how you're doing. Okay, so again, so if we f of x is x squared minus 9, and g of x is x plus 3, and we'll make h of x x over 3. So if I'm going to do g of x divided by f of x, so I have x plus 3 divided by, we know x squared minus 9 is going to be x plus 3 times x minus 3, because that's a difference of squares. So x plus 3 divided by x plus 3 is 1. So when we simplify, we end up with 1 over x minus 3. And in this case, if x is positive or negative 3, this isn't going to work out for us. So we can do interval notation, or we can do inequalities, or we can say all real numbers where x is not equal to positive and negative 3. So that would work also. Okay. For the next problem, we're going to do g of x divided by h of x. So g of x is x plus 3 divided by h of x, which is x divided by 3, or 1/3 x. And we remember that when we divide by a fraction, we're really multiplying by a reciprocal. So we can rewrite this as 3 over x times x plus 3. And when we distribute, 3 times x divided by x, so x divided by x is 1. So this would be 3x over x plus Remember, these are all over 1.
2:30 in the auditorium. Also, seniors, please remember to get your lunch pass stickers. Seniors, please remember to get your lunch pass stickers. If you receive a challenge day invitation, please make certain to turn it in, signed to guidance before November 2nd. If you receive the challenge day invitation, please make certain to have it signed and turn it in to guidance before November 2nd. As a reminder, homecoming tickets are on sale this week. You can get a Spirit Pass homecoming that will cover all the events for homecoming. Next week is homecoming. The cost is $30 to participate in all the events, including the dance. It does not include the football game. Football game would be separate, but everything else other than the football game, for $30 you can get the Spirit Pass to get you into all the other activities for homecoming week. And also a reminder, picture retakes, IDs are available to be picked up in the front office. You may pick them up before school, after school, during break, or during lunches. And this is all our afternoon announcements. At this time, seniors, if your teachers are ready for you to be dismissed, seniors may be dismissed. All other students, please wait until the dismissal bell rings, and we hope you have a wonderful evening.
Times 3, so this is 9 over x. So x over x is 1, so we end up with 3 plus 9 over x is our answer. And the domain can be anything, but we can't have 0 in the denominator. So real numbers where x is not equal to 0. Okay, so in this last one, I want you to pause the video if you haven't already and try this one. It's kind of the challenge question. And we will be right back. Okay, so this is f of x, so this is x squared minus 9, divided by g of x, which is x plus 3, times h of x, which is x over 3. Now, we've already done this first part, f of x divided by g of x. So we know that that is x plus 3 times x minus 3 over x plus 3. And then if we multiply in the x and the 3, now we have x plus 3 divided by x plus 3 is 1. So we have x plus 3 times x over 3 as our final answer, because x is in the numerator, and we have x minus 3 all over 3. And when we look back at what was in our denominator, so it was all real numbers where x is not equal to negative 3. And so there's our final answer. Okay, function composition is where we're going to put a function into another function. So that means we're going to start with the interior function, so g of x. So we'll calculate g of x, and then we're going to put whatever we get from g of x into the f of x function. Okay, so if I'm saying g of f of x, that means the g of f of negative 5. Okay, so what that means is I'm going to find f of negative 5 first, right? So f of negative 5 is negative 5 minus 2, which equals negative 7. And so then I'm going to take that negative 7 and I'm going to find g of negative 7, because f of negative 5 is negative 7. So g of negative 7, and so g of negative 7 is negative 7 squared, which is 49. So therefore, g of f of negative 5 is 49. And we can do the same thing here. So we know f of g of negative 5, and so now we're going to, the input, it goes in the g function first. So g of negative 5 is negative 5 squared, which is 25. And so now, if g of negative 5 is 25, we want to find f of, remember, f of g of negative 5, which means we want f of 25, because g of negative 5 is 25. And so f of 25 would be f of 25 is 25 minus 2, which is 23. So f of 25 is 23. Okay, so the next problem, g of f of x. So for x, I'm going to first put x into my f function. So my f function is x minus 2. And I'm going to take what I know about my f function. Remember, f function, f of x, is x minus 2. So g of f of x is x minus 2. So now I'm trying to put x minus 2 into my g function. So remember, my g function is x squared. So that means I take whatever I'm putting in and square it. So I'm doing x minus 2 quantity squared, which we then expand to x squared minus 4x plus 4. And so g of f of x is x squared minus 4x plus 4. Okay, so in this example, we're going to substitute functions or expressions into other functions. So here, f of g of c means the f function of the g function when you put in c, right? So we're going to put in c to the g function first, and whatever we get out, we're then going to put it into the f function. So we're going to do f of, and the g function says square something and then add 1. So something squared plus 1, which of course is c. So g of c is c squared plus 1. So we're going to put c squared plus 1 into our f function. And our f function says take something, add 1, and divide by 2. So f says put your input, add 1, and divide by 2. So we're going to put c squared plus 1 into our f function. So if we put c squared here, c squared plus 1, and we simplify this, now we have c squared plus 1 plus 1, so that's c squared plus 2 over 2. So f of g of c equals c squared plus 2 over 2. And we can do this repeatedly with any number of functions. So here this says g of x. So here we're going to do g of x. So g of x is x squared plus 1. So g of x squared, oops, I should do that in red, x squared plus 1, because that's the g function. So if we put x squared plus 1 into the g function says take your input, x squared, and then add 1. So if I put x squared plus 1 here, and I expand, I have x to the 4th plus 2x squared plus 1 plus 1. And simplified, x to the 4th plus 2x squared plus 2. Go ahead and pause the video, try part C, and we'll be right back. Okay, so in here, we're going to do g of f of 2x plus 1. So f of 2x plus 1 says, so we'll put the g on the outside so we don't forget about it. F of 2x plus 1, so the f function, says take your input, so 2x plus 1, add 1, and then divide by 2. So when we simplify that, we have 2x plus 1 plus 1, so that's 2x plus 2 divided by 2, which everything here is divisible by 2, so we could factor out a 2. So we end up with g of x plus 1. So the g function says square your input and add 1, right? X squared plus 1. So we're going to take our input and add 1, and our input is x plus 1. So when we expand this, we have x squared plus 2x plus 1 plus 1. So our answer is x squared plus 2x plus 2. Okay, so in general, we call inverse relations the set of ordered pairs we find by exchanging the coordinates of each ordered pair. This means that if AB is an ordered pair in the function or relation, BA is an ordered pair of its inverse. We can write the inverse of a function as f of x. So if the function is f of x, it's the inverse of f of x. We don't say f to the negative 1 because raising something to the negative 1, remember x to the negative 1 is 1 over x. That is not an inverse. That is not what we're talking about. We are talking about the inverse function of x, and you read that as the inverse of f of x. That's how we say that, the inverse of f of x. If both the relation and its inverse are functions, then we can call them inverse functions. So we can only refer to them as inverse functions if both the relation and its inverse are functions. Okay, so very basic. If we know A is 1, 5, 2, 6, and 3, 7, then its inverse, B, is going to be the x and y pairs switched. So 5, 1, 6, 2, and 7, 3. And so if I graph these, so if I graph A in blue, so that's 1, 5, and then 2, 6, and 3, 7, and then I graph its inverse, which was 5, 1, 6, 2, and 7, 3, you can see that there's a little bit of a pattern, and we're going to talk about that pattern in just a moment. In the meantime, if the function f and its inverse are inverses of each other, then we can use function composition and the idea that if f of a equals b, then f of b should equal a. That is, we can switch the x and y values. So another way to think about this is f of x equals y, then the inverse would the inverse of that function, so f of y equals x. So we can switch x and y's. So for example, if we want to find the inverse of f of x equals x minus 4, we can evaluate f of 6. So put in for 6, 6 minus 4 is 2. So if f of 6 equals 2, then for its inverse, the inverse f of 2 should equal 6. Remember, we can switch. So if we find the inverse of f of 2, that equals 6. And so we can see that the x values switched and the y values switched. Okay, so because f of x and its inverse are inverses, f of 6 equals 2, and the inverse f of 2 equals 6. Graphically, if we graphed y equals negative 4, y equals x minus 4, and we graphed y equals x plus 4, we can see that they're parallel, but they share a special relationship across this line, y equals x. And we're going to talk about that a little bit in just a moment. So for starters, if you want to find an inverse function, the first thing we're going to do is switch x and y. So if we know this is f of x, then that means that y equals x squared minus 1. So to find the inverse function, we're just going to switch x and y. So x equals y squared minus 1. But this doesn't really give us a function. This gives us something in terms of y. We want to write things in terms of x. So first thing we're going to do is switch x and y, and then we're going to solve for y. So we need to add 1 to both sides. So we have x plus 1 equals y squared. And now that we have y squared, we don't want y squared. We want just y. So if we take the square root of both sides, we end up with y equals the positive or negative square root of x plus 1. So I want you to go ahead and try that. Remember, we switched x and y, right? Switch x and y, and then we solved for y. So I want you to take a moment and do that. Okay, welcome back. So there's the answer. If you're not sure how we got it, we can talk a little bit about it when you come back to school. Okay, so what if we were to graph those? So if we graph x squared minus 1, right, that's a quadratic down 1. So it's going to have points here, and 2, 2, 4, 2, 2, 4, and so if you made a quick XY table, right, if we put in -3, we get out 9, 8. If we put in -2, we get out 4, 3. If we put in -1, we get 0. If we put in 0, we get -1. If we put in 1, we get 0. If we put in 2, we get 3. And if we put in 3, we get 8. So you can go ahead and graph those points. So 3, 8. And so here's our function. Okay, and if we graph the inverse function, so let's pick some x, y values. Now, we're saying it's an inverse. So if I put in 8 for x, right? 8 plus 1 is 9. Square root of 9 is 3. But we're saying positive or -3. So if I put in 8, I should get 3, and I should get -3. If I put in 3, 3 plus 1 is 4. Square root of 4 is 2, so I should get positive 2 and -2. If I put in 0, I should get out positive 1 and -1. If I put in -1, I get out 0. And so if we graph this function, and I'll graph this in green, if I -1, 0, and then 0, 1, and -1, and then 3, 2, and -2, and then if I go out 8, I can go up 3 and -3. And so I recognize that this, first of all, is not a function, right? Because it wouldn't pass the horizontal line test. But I notice that there's a symmetry here. And in fact, these graphs are symmetric about the line y equals x. And that is one way to tell if a relation, or if two relations are inverses. They will be reflections of each other across the y equals x line. Okay, so go ahead and try this and determine what the inverse of y equals 2x plus 8 is, and graph both of them and see if it's symmetric about y equals x. Okay, welcome back. So when you graphed 2x plus 8, and then its inverse, which was y equals 1/2 x minus 4. So its inverse was y equals 1/2 x minus 4. And you notice that the domain and ranges were both -infinity to infinity. Okay, so in general, if we graph inverse functions, it will always be a reflection across the line y equals x. So just like the vertical line test is used to determine if a graph is a function, we can use the horizontal line test on the original function to determine if its inverse will be a function. If the inverse is not a function, the domain of the original function can be restricted so that the inverse will become a function. So, for example,